Yeah, so in terms of history, we all know that graph theory was born in 1736 when Euler solved the famous Königsberg bridges problem. But hypergraphs were born much later. And in a 1994 paper, Erdős wrote, "As far as I know, the subject of hypergraphs was first mentioned by Galley in a conversation with me in 1931. So hypergraphs are less than 100 years old. And today, quoting a reviewer from a grant I applied for, hypergraphs are current and hot."
So why did we want to do this program? Well, hypergraphs are a relatively new area of mathematics. They draw in expertise from lots of different disciplines, from pure mathematics, from applied mathematics, from theoretical physics, from computer science. We wanted to convene this sort of multidisciplinary community to explore these questions, explore these problems, and see where we could take hypergraphs in the future.
So the field of higher order networks and hypergraph is really blooming, and there are a lot of important results, and specifically in the combining algebraic topology and discrete geometry to dynamics, and this is giving unprecedented collective phenomena that have been not explored so far. And so the idea of the workshop was to bring together people from different community and discuss about common problems, and each one coming from different perspectives, so including theoretical physics, computer scientists, and a pure mathematician. And the challenge is to really build a mathematical foundation for this new field. And my belief is that although this is has connection with geometry and topology, really this theory cannot do without information theory.
So the program is structured so that the first week was a kickoff conference, and it was quite intense with many talks, and we heard a lot about the past research that has been done, while the following 3 weeks are kind of more relaxed. We have less seminars and talks, and we have more time for discussions and actual research. So that's the moment for us to follow the new directions. And we have to make the best out of it, because we are in the middle of the summer. We could be on a warmer island, swimming in the sea, or on a mountain if you're a mountain person. And instead, we are here, talking about hypergraphs.
So I work on the theoretical side of mathematics, and I am an algebraic graph theorist. And I work on things like matrix algebras and graph eigenvalues and their applications in many fields like quantum computing. And in the study of the eigenvalues or spectra of directed graphs and hypergraphs and these newer objects, there's a lot of space for exploration. So for graphs, this area is very well developed. There's a lot of literature and a lot of research in many areas. But for hypergraphs, it's like a brand new world. And then if you could do anything in the world, what should you do? It's a difficult decision that is sort of guided by what are being studied in applications. So this workshop has been bringing together the theoretical side and the applied side of hypergraph research, and I think that this is very stimulating for the area, for the theoretical side.
In January of 2024, myself and 4 other mathematicians, our collaborators, received the prestigious EMS Leroy Steele Prize for seminal contribution in mathematics. And the main topics of those papers is the hypergraph container method that we invented about 10 years ago. And during this workshop, I explained the hypergraph container method and talked about various applications which might be surprising for many people. And the hope is that by the interaction of other participants of the conference, we might have new unexpected applications of the method.
As an early career researcher, I find this program very exciting for me. For one thing, it covers relatively broad topics in the whole picture of hypergraphs, from the theoretical part, more mathematics, and the more application part like like machine learning, the hot topics we have now. And then with this program, I know like where my research could fit in these broad areas and also where I can go in the future. So it's very, very helpful for me as an early career researcher. And on the other hand, it has a relatively flexing or relaxing schedule. So we have plenty of time to discuss with other researchers, and I find it really, really helpful because we can not only discuss the problem at hand, but also the problem in the future, which could lead to like future collaborations, and that's also very helpful for us as a local researcher. And on the separate note, also the number of people or participants is not as big as a conference, so I can talk to all of them and also know their expertise. For these, in the future, if I have some problem at hand and I need some help from like people with specific expertise, I know who to talk to. So that's also very, very helpful for me.
Oh, what the future of this field is a question that I don't know precisely. I have an opinion, and according to my experience, if somebody will ask me this 10 years ago, I will not be able to reply that we are here in this higher order with hypergraphs methods for complex systems. But the thing is that it's amazing how this dynamic field is going on in many different fields with applications in an interdisciplinary area in which you have artificial intelligence, algebraic topology, mathematics, or very complex systems problems from a physics perspective. I will say that this kind of theory that we are trying to develop here, it will be the future for many things, as for example, as it has been right now, to control an epidemics.
I see a lot of applications of this theory. In particular, I think that even though graph theory has been fundamental from many application and theoretical points of view, but still it is time to go beyond graph representations, because in many complex systems the whole knowledge of the system cannot be reduced to pairwise interactions, which essentially is what graphs do. But we need to go beyond and incorporate multi-way relations between the many entities involved. And in particular, one of the fields where I think the application of hypergraph theory, and especially the algebraic topology, is going to have an impact is in artificial intelligence, and more specifically in the study of deep neural networks that play a fundamental role in machine learning, because one of the major issues there is the so-called explainability, our capability to explain why deep neural networks are able to achieve the results that they indeed are able to achieve. Well, to be able to improve our capability of obtaining this explainability, I think we need to incorporate within the architecture of these deep neural networks some fundamental invariants, some fundamental properties that can only be captured by resorting to algebraic topology and hypergraph theory.